Morning everybody, welcome back. In the previous two videos we looked at Allen Bradley RSLogix 5000 and we also looked at Siemens TIA Portal. What we're going to be doing today is we're going to be looking at Siemens STEP7 Professional. If you look at TIA Portal and RSLogix 5000, those are two of the best programmers at the forefront of automation right now. However, STEP7 Professional is still being used on the shop floor as well as a lot of the older predecessors as well. So we're going to take this time, about 30 minutes, just to get you used to using STEP7 Professional, get used to understanding how to set up a project, creating hardware configuration, because it is slightly different to TIA Portal and quite different to RSLogix 5000. And what we're then going to do is show you how to connect to the PLC and also download to the PLC. So what I want to do is I want to get started working with the Siemens S7 PLC. So I'm just going to flick you over to the main screen so you can actually see an image of what we're going to be working with here. So on my laptop at the moment, what you'll see is the Siemens S7 that we're connected to. If you look on the left hand side here where my mouse is at the moment, this guy is the CPU. Alright, this is what we are connected to, and we're connected via its MPI just underneath this flap here. And very similar to your ControlLogix PLCs as well as S7 1200 PLCs, you've got your LEDs telling you the status of that PLC. So you've got SF at the top here. This is your system fault or your status fault, however you like to call it, and that there will glow red when there's a system fault or a hardware fault on the actual PLC itself. Now to find out that, how to find those faults themselves, is to go to STEP7 Professional and use the CPU diagnostics tool, and that diagnostics tool should tell you why that system fault LED is on. The next one underneath that is your battery fault, your BAT-F, battery fault, battery failure. That there will turn on when your battery is low or there is no battery connected. If you do see that battery light turn on, you must get that replaced as soon as possible. Underneath that is DC 5 volts, and you can see there it's currently glowing green. That tells us that the CPU itself is seeing 5 volts DC. Underneath that, your force indicator, that there will be orange when there's a force actually active on this PLC. Underneath that, you then have your run and stop, and obviously if the run light is on, your PLC is running, and if your stop light is on, your PLC is stopped. There you can see you've got an actual key switch. This can differ from PLC to PLC on the S7 300s. It depends upon the CPU. Older CPUs tend to have this key switch which you can actually just turn to the right selector. The other one is sort of like a flick switch. It has three positions. It has an up position, a middle position, and a down position. The up position is the run mode. The middle position is your stop mode or your program mode. And then the bottom position is your master reset. Don't press the red button. Here we have Run P and Run. Now this is what the new selector switches sort of got rid of. Now you just have Run, okay, and it's because Siemens found out everybody was just using Run P instead of just the Run. The difference between the two is if your selector switch is in the Run position, the PLC is running the program, but you can't download to it, you can't make any modifications to it. The Run P, however, you are running the program, but you can also make modifications, so you can make online edits to the actual PLC program itself. A lot of the times people just leave it in that position there. And in the bottom area we have our stop, that there stops the process, and then we've also got our master reset again, our memory reset. Again, don't press the red button. Now this CPU is a CPU 314IFM, and I can see that just at the top of this CPU here, and at the bottom you'll actually see the product code for this CPU, and this is important. We're going to need this for our hardware configuration later on. Next to the CPU you're going to see two I/O cards. This one here is a digital input, so it's a 4-way digital input, DC 24 volts. It's also an analog input 4-way, and it's also an analog output 1-way. So we've got one analog output on this card. So here we've got quite a bit of addressing on this card here. And you can see next to this analog, just quickly, it says 12-bit. That's the resolution of the card. Alright, that allows this card, I think, to work from 0 to 4096 scale. Or if you're, let's say, working on a 420 milliamp, that they'll be on a 0 to 4096. This here, you'll notice there's no product code at the bottom, and it's the same with this 16 input, 16 output card. There's no product code at the bottom. That's because these two actual cards are connected to the CPU by default, the part of the CPU itself. Now, this doesn't make the CPU a compact PLC. It's still a modular PLC. It's just a special type of modular PLC. It being a 314 IFM, it has these 2 additional cards joined onto it. Now we do have additional I/O cards, and you can see here we've got a digital input 32-way just at the top there. We've also got, what I'll do is I'll zoom in a little bit so you guys can see it if you can't see it from where you are at the moment. At the top you have a digital input 32-way DC 24 volts, a digital output 16-way 24 volts again, and we've got another analog card at the end there which is a 4-way, again it's 12-bit. Now you'll notice this analog card has a system fault on it, nothing to worry about there, it's just because there's no terminal block connected, so it's effectively an open circuit. At the bottom of these cards, if I just scroll down to the bottom here, you'll see there's product codes. And these product codes are unique to these cards, so we're going to need this information later on when we're actually working with the hardware configuration and setting everything up. But overall, this is the PLC that we're going to be working with and we're going to be connecting to. So what I want to be able to do is I want to be able to create a Simatic Manager project using STEP7, want to create the hardware, get some communications going, and then download that to the PLC. So let's open up STEP7 Professional. So at the bottom, I've got Simatic Manager STEP7, and what I'm doing is just open this project and it'll just appear as blank. Okay, now what we're going to do is we're going to create a brand new project. So to do this, again, you can just click the file, the new project icon, or you can go to file and you can select new. Don't select new project wizard. New project wizard is a sort of like Siemens own task manager to help you create your own project. The problem is with new project wizard is it doesn't have the full catalog available to you. So what we want to do is we want to just create a new project so we get access to the full Siemens catalog. And what we're going to do is we're going to give this a name. So I'll just give this a name, Chris_test. And if you look here, you can see the storage path, and the storage path is your program files, Siemens STEP7 S7 Proj, and that there is the default storage path for Siemens project. We're just going to leave it there, and we're just going to select OK, and you're going to get a brand new project opened up in front of you. Now, the biggest thing about Siemens STEP7 to TIA portal is the fact that we work with windows inside of STEP7 instead of tabs. So here we're working all inside of these different sorts of windows, and as we start to open hardware configuration, more windows will open up at the bottom of my taskbar here. I'm just going to go full screen so I can get a better picture of it all. And we can see on the left hand side is our project tree, and you can see there's our project there, Chris Test. And on the right by default is your MPI. Nothing else is available to us from here. What I want to do is I want to double click our MPI, and this will open up our NetPro window. And like I say, it's opened a brand new NetPro window. It hasn't opened it up into a tab like TIA portal would. I'm just going to go full screen here, and again going full screen on our NetPro window. Moving this down to the bottom just so I can see my work area a little bit better. You can see here I've got my MPI rail. Now the way we're actually connecting to the PLC is via the Siemens MPI lead. And what we want to do is we want to add a station to this NetPro window. So to do this, on the right hand side, look for the folder called stations, open this up, go to Simatic 300 and either drag and drop it into place, or you can just double click it. I'm just going to drag and drop it into place, and I'll move your Simatic 300 there. Now what I want to do is click the floppy disk, and that there is your save icon. So click that, and then just close down your NetPro window. And now what you'll see is next to your MPI is your Simatic 300 station, and you'll also see a little expansion icon next to your actual project. If we expand this icon, you can see there is your Simatic 300, and if I expand this again, nothing else appears. If we double click Simatic 300, you'll now see a new window open up on the right hand side, and that there is your hardware, and this here is your hardware configuration. Now we're going to show you how to complete an entire hardware configuration because it's slightly different to how we would do it in TIA portal. So just double click on hardware configuration, and it should open up the new hardware configuration at the bottom there. And again, just go full screen and go full screen again. I tend to like to go full screen just so we can see everything in front of us. On the right hand side is your hardware catalog, and you can see here we've got a SIMATIC 300 folder. Now if I just open up the SIMATIC 300 folder, you've got different types of folders inside of there. And the first thing that we need to do is we need to add a rail to our project. And this rail is like the chassis inside of an RSLogix 5000 project. It's like the backplane on an Omron C200H PLC. This is where we actually attach all of our cards to. Now the difference with the SIMATIC 300 project is it's just an aluminium rail. There's no physical connections, there's no PCB for you to connect your cards to. What you have is you have bus connectors, which is just sort of like plastic connectors that clip into the back of the actual cards to link them together, and then the cards sort of like just latch onto the aluminium backplane itself. But we need to add this backplane first of all before we add any sort of cards to the project. So to do this, we open up the folder called Rack 300, and inside of there will be your rail. Again, you can drag and drop, or you can just double click, and there's our rail in front of us. I can expand this, and you've got 11 slots on this rail, and at the bottom is your overview, your sort of detailed overview of the actual rail itself. So as we start to add cards and modules to these slots here, you'll start to see the order numbers, firmware revisions, addresses, input addresses, output addresses, all sort of come and populate at the bottom there. Now, with Siemens rails here, with the S7 each slot has a specific function, alright? So you can't just drag and drop them anywhere you want. So for example, slot 1 on a Siemens PLC is for the Siemens power supply unit. Now if we just go back to our picture here of our Siemens PLC, we don't have a Siemens power supply unit. This is to the left of the PLC. All we've done is we've just wired a third-party device to the actual power supply on this PLC. So we've just got 24 volts coming in here. So because we don't have a power supply unit, this slot here is going to be blank. The next slot is for your CPU. So for me to find out what CPU I want, I first of all want to look for the CPU 314IFM. So if I just go back to my project here, look inside the CPU folder, and if we just look down this list, you'll see the CPU 314IFM. Expand that folder and you get different product codes available to you. Now what we want to do is we want to go back to our CPU and have a look at the product code here. And you can see there we've got the product code 5AE010AB0. And if we go back to our hardware catalog, 5AE010AB0. That there is the product code that we want. Now when we click on this, you'll notice slot 2 highlights green. This is telling you this is the only slot you can move the CPU to. So you can either double click it or you can drag and drop it onto the correct slot. So I'm just going to drag and drop it onto there. And you can see our CPU has now populated that rack. And if you look here at the bottom, our detailed overview, you'll see there's your CPU, there's your order number, and here are your I/O addresses. And if you look there, it starts from I124.0 all the way up to 135, and our output addressing is also I124 all the way to I129. These are the bytes that we're using. Next, what I want to do is I then want to add in the I/O cards. Now the I/O cards don't just go into 3, 4, 5 all the way to 11. Slot 3 is for your IM, and that there is your interface module, and what that allows you to do is it allows you to link to expansion racks. Because we don't have an expansion rack, because we don't use an IM module here, we're just going to leave that blank. And slots 4 to 11, they become where your I/O cards go to. So again, what we want to do is we want to go back to the image, and then we want to populate the cards here. We don't need to populate the first two because they're part of the CPU. It's only these 3 cards here. So the first one is a DI 32-way DC 24 volts. So again, go back to your hardware catalog, open up your SM300 folder, and then here are our cards. So we're looking for a DI, and it's a DI 32-way DC 24 volts. And there's actually 2 of them available here. So depending on our order number, will tell us which one to add to our project. So let's just go back to this. And at the bottom, if I just zoom in here, it's your 321 1BL00 0AA0. So we want our 1BL000AA0. That's the guy that we want. Drag and drop that into slot 4. And then do the same for our output card. So our output card is DO16, DC 24 volt. So just go to your DO folder, and you want DO16 24 volt, and there's actually quite a few of these ones. So we've got quite a few available here. Again, looking at the product code will tell us which one we want. So we want the 1BH01 0AA0. So that there is 1BH01. Not that one. Not that one. Not that one. There we go. 1BH01 0AA0. Drag and drop that into position. And then the final card is our analog card. Our analog output 4-way 12-bit. So just close down DO. Go to your analog output folder. And we're looking for analog output 4. 12-bit, and again there's 2 of them, so all we need to do, just scroll down to the bottom, 5HD001 0AB0, go to your hardware catalog, and not that one, but that one there. And there we go, that there is our chassis configured, our rack or rail configured. Just save our project here. There we go. Now if we just click on this rail, again, all of your addressing appears down here. So if we look here, our input addressing starts with 0 and ends at 3. Our output addressing starts at 4 and ends in 5. And then our analog addressing starts with 288 and ends in 295. So when I'm using my inputs and outputs in this stream here, I'm going to be wanting to use I0.0 for example, and I can use it from I0.0 all the way up to I3.7. Remember, Siemens works in bytes, and a byte is 8 bits. So your first address is I0.0 to I0.7. Then I1.0 to 1.7, 2.0 to 2.7, 3.0 to 3.7, and my output addressing is going to be Q 4.0 to 4.7, Q 5.0 to 5.7. Make sure we just save that, and then just close down our hardware configuration. I can actually just get rid of this image as well here. Not interested in that anymore. Now what I want to do is I want to go back to my MPI folder. If I go back to MPI, there we go, you'll see inside of our Simatic 300 is now our CPU. What I want to do is I want to link the CPU to our MPI rail. And to do that, there's 2 ways to do it. One way is you can right click this, go to Object Properties, go to Properties, and then select MPI. Another way to do it is double clicking the actual square here, and it brings us straight to that MPI interface. And then all we want to do is we want to select our network that we're on, an MPI network, and then just select OK. And that there will now connect our CPU to our rail. Now what we want to do is we want to save and compile this project. So save and compile on Net Pro, because we're finished with this. So click the floppy disk with the 1s and 0s, and that there is your save and compile. And what this is going to do is I want this to compile and check everything. Say OK to that. No errors, which means everything's hunky-dory. Close down our Net Pro window, and now select your Simatic 300 and select hardware. And now what we want to do is save and compile our hardware as well. So save and compile that. No errors popped up, so we're all okay there. Next is to download the project to the PLC. To do this, we just select this download to module icon. Before I do this though, I want to make sure that my communications are set up correctly. Minimize your hardware configuration, go to your options window in Simatic Manager and go to set PG to PC interface. And when you do this, all the different types of interfaces pop up here. And the interface that we're using is our PC adapter MPI, but you've got quite a few different ones available to you. Alright. All we want to do here though is select PC adapter MPI, there we go, and go to properties. Now, a lot of the times you can just leave this as default, but if you want to tweak it, you can do from here. So if you want to tweak the transmission rate or anything like that, you can do that from here. Just select OK. Close that down. Go back to my hardware properties and then just select download to module. It's going to ask you which module do you want to download to, and because the 314 is our only one that's connected, that's the one I want to connect to. Select OK. And then what it's going to do, it's going to ask you to search for accessible nodes. So select view, and you should see the accessible node appear down here, and there it is. Just make sure that's highlighted and then select OK. And it's going to start downloading to the PLC. Now the first thing it's going to ask you is the following modules will be stopped for loading of the system data. Select OK. Now remember, when you do this, just like other PLCs, when you do a full download, it's going to stop the PLC from running. So all we want to do here is make sure that the process is stopped. Safety sakes, place it in the E-stop, and then select OK. This is then going to drop the PLC out of run mode into stop mode. And now it's asking you, do you want to do a restart and start the actual module again? Just select yes there, and there we go. That there is our hardware setup configured. So all we did there, just to recap, is we first of all opened up our project, opened up MPI, opened up your stations, dragged and dropped the station into place. We then went to our SIMATIC 300, opened up the hardware, and then configured the rack from what we are using on our board here. Then we just linked up the actual station to the MPI, compiled that, and then downloaded it to the PLC via the hardware window once again. Okay, that there is setting up the actual project. So it's slightly different to how we did it in TI8. In TI8, all we did is we said, right, just let's upload this. But because it's a little bit more involved here, I wanted to go through each step and show you how to set up a hardware configuration inside of Step 7. All we want to do now is we want to create a program. So open up your folder all the way down to the last rung, and you should see a folder called blocks, and by default there is your Obi-Wan created. Any Star Wars fans, remember this is your Obi-Wan Kenobi, the main guy. Double click Obi-Wan and it'll ask you to create the block. It might say, do you want to give it a symbolic name or anything like that? Not interested in that. All I want to do though is I want to change the created in language to ladder, not STL. Select ladder and then select OK. And now what it's going to do is open up another window, and this is going to be your Obi-Wan program. And all we're going to do is we're going to create a very basic program just using contacts and coils and another timer again to show you the timers as well. Now, just a little bit of an overview. At the top here, you have your block interface where you can create internal tags to the block. I'm not going to use any internal tags to this block, so all I'm going to do is just minimize that all the way. And all I did there was just dragged and dropped it right to the top. The left hand side is where your instructions window is, and you can actually enable this and disable this via this icon at the top here. If I click this icon, it disappears. If I click it again, it reappears. And at the bottom is your output window, and again, clicking the icon to the right then allows that to be enabled and disabled. I'm going to leave that disabled. What I want to do is just leave my instructions window opened. You can see here we've got network 1 available to us, already ready for us to create. Let's add in the most commonly used instructions, your contacts and your coils. So I'm going to create a start-stop latch again, and to do this I'm just going to place it a normally open contact, like so. A normally closed contact, whoops, I've clicked that twice. An output coil. And there we go, there's a rung created. So all you do is just click, 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 adds them one after the other. Very straightforward, very simple. What I want to do now is I want to create the latching bit, which is ORed around our normally open contact. To do this, either click at the very start of the network, the vertical line or the horizontal line. Either one will work. And then what you want to do is select open branch, and this creates another rung inside of this network like so. Click your normally open contact and then select your closed branch, and this then links this branch upwards to the top rung. You can also drag and drop the arrowhead if you wanted to. Let's give this an address. So I want to give this an address. I'm not going to use an input, I'm going to use an M bit. This will just allow me to toggle it. So I'm going to use it the very first M bit, M0.0. And then for the next one, I'm going to use M0.1. This is just going to allow me to just toggle the bit instead of creating a force on this. And for my output, I'm going to use M10.0. And this is going to be my run signal. M10.0. There we go. Let's give these names or symbols. Again, there's two ways to do this. You can either double click inside of the blank space inside of this network. And what this does is it opens up your edit symbols for that network. You can also right click and say edit symbols. Or you can go to options symbol table, and this gives you the whole symbol table for the entire project or for this entire block. So what I want to do is, I can just leave that as it is. I'm going to just open it up from this network, and there's my addresses already created for me. M0.0 is going to be my start PB. M0.1 is going to be my stop PB. And then M10.0 is going to be my process run signal. There we go. Like so. And what you can do with this as well is there's a little tag here, a little tag icon, and what this does is it allows you to invert the addressing style. So you can have it so that the label is at the bottom and the address is at the top, or the address is at the bottom and the label is at the top. And I prefer this style here. So when I go in, I can just straight away edit the address from here. If it was similar to this, I would have to delete this entire name and then write in the address from there. I just like to leave it so the address is directly above the contacts and coils. Now what I want to do next is create another network, and to do this just use the new network icon, or you can right click and say insert network. I'll just use the new network icon, and I want to add a normally open contact, and that there is going to be M10.0, my process run signal. And what I want to do now is add in a timer, and if I look on the left hand side, you got your timers folder. If I expand timers, here are all of the timers inside of step 7. There's a lot more than there was inside of TI8, and a hell of a lot more than there was inside of RSLogix 5000. You've got the S_pulse, the S_PEXT, the S_ODT, ODTS, and OFF-DT. You've also got the same versions of those timers. However, these are the S7 style timers. The difference between the two is one is a block format, the other is a coil format, like so. And that there is exactly the same timer, works in exactly the same way. However, one is a block format, the other is a coil format. We're just going to stick with the block format. I prefer the block format for two reasons. One, everything is neatly placed in one area. I can then tie as well output coils after this, and I can also do contact addressed to the timer. So when I give this timer a name, let's say T0, I can place a contact addressed to T0, and that will turn on exactly the same way it does with the S7. But if I don't want to do that, I can simply just place the coil after this. So what I want to do is have this run signal control this timer for 10 seconds. Now, if I just type in 10S and then press enter, unexpected input end, it doesn't accept it. You can't just type in 10S like we did with TIA Portal. You have to use the Siemens timer code, and the Siemens timer code is S5T#10S. And there we go. So S5T#10S, that allows us to then use our timer value for this timer as 10 seconds. Now what I want to do is I want to add an output coil, and I want to try this output coil to my actual output on the PLC, Q4.0, and then what we'll do is we'll just edit the symbols and we'll just call this lamp. Okay. Like I say, that there is exactly the same design as the SD. The only difference is the SD is a coil. In fact, what we'll do, just to show you this, I'll create another network, again, using M10.0, and this time using the SD. I'll give this T1, and again, S5T#10S, there we go. Now if I want to address this to an output coil like we did up here, I've got to create another rung, and I've got to add a contact, and this contact is then going to be T0, and I'm going to use another output coil from there, and then I'll just use Q4.1, and I'll just call this lamp 1. So here we've got two networks, exactly the same design. When the process run turns on, the timer's going to run, and then after the 10 seconds, it's then going to turn on an output coil. The only difference is in network 2, it's a lot more compact and structured. However, with network 3, you've got two rungs to control it and do the same thing. What I want to do is just save my project, and then just download it to the PLC. I'm going to click download, and it's then going to ask you, do you want to override the block? I'll just say yes to that. And there we go. That there is then downloaded that to the PLC, and we're ready to go. If I just click on the glasses here, the monitor icon, this allows us to monitor the program. You'll notice, however, not all networks are being monitored. Only these two networks have. This network hasn't. If I click in this network, there we go, it refreshes itself and allows it to be monitored. There's a few little bugs inside of STEP7 that you'll come across, and these are a couple of them that we've noticed when we're actually working with the programmers. Now you'll notice that this is already timed out, everything's been running, and this is because this signal here, M10.0, would have been already latched on previously when I downloaded to this. If I just modify this to 0, and then modify M0.0, there we go, and modify M10.0. There we go. We're ready to start from afresh here. Chances are people who were using this PLC beforehand was using M0.0 or M10.0, more likely M0.0, and that was already latched on inside of the process memory, so when we've downloaded to it, it started running the program. All I've done there is I've just reset everything. So to run this, what I'm going to do here is I'm just going to right click M0.0 and I'm going to say modify to 1. What this will then do is it'll close this contact, turn on M10.0 and latch it on. Okay. Then what's going to happen is M10.0 is going to turn on from here, run our timer, and run this timer down here. After 10 seconds, it's then going to turn on our lamp. So we're going to do this, and you should see it happen. Modify to 1. There we go. Both M10.0s are on, and you can see it's beginning to time out. 3, 2, 1, 0. And there we go. Both timers have now turned on, and both outputs have turned on as well from the actual timers too. As soon as I disable this latch, so if I modify that to 0 and I press our stop push button, M10.0 turns off, and the contacts turn off, and the timers reset, turning off the output coils as well. And that there was just a very quick introduction to Siemens STEP7, creating hardware configuration, creating a basic program, and then downloading that to the PLC. Hope you guys have enjoyed it, and I look forward to seeing you again.